we have seen how to solve for HNs using recurrence relation of HN using substituting HN as q to the n and solving for it. But there's another technique that is quite useful for solving them, solving the recurrence relations, and that is by using generating functions. Now, this is a slightly bit more involved, but as with generating functions, sometimes the generating function is easier to get and you know more about it than your sequence HN. If your sequence is too complicated, it might be easier to work with HN to get back to your sequence, right? And so let us look at the technique using generating functions. Example, solve the recurrence, CURR, recurrence h of n is equal to 3h of n minus 2 plus minus 2h of n minus 3. Okay, with the constraints h of 0 is equal to 1, h of 1 is equal to 0, h of 2 is equal to 0. Okay, and we want to do this using generating functions, using generating functions. Okay, so solution, consider the generating function g of x is equal to summation n is equal to 0 to infinity h of n x to the n, right? Then observe, well, summation n is equal to 2 to infinity h of n minus 2 x to the n is simply a summation, let me say m is equal to 0 to infinity h of m x to the m plus 2, right? And m and same difference, this is just x squared g of x, right? Both of them are just names for the same variable that I'm summing things over. So it's x squared times g of x. Similarly, if I start the sum at n is equal to 3, h of n minus 3 x to the n, this is summation m is equal to 0 to infinity h of m x to the m plus 3, which would be x cubed g of x, right? And so if I go back and look at my recurrence relations, I am solving for g of x minus 3x squared g of x plus 2x cubed g of x. Okay, now g of x is h0 plus h1x plus h2x squared plus h3x cubed plus dot 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 minus 3x squared g of x is, the first term is going to be at x squared minus 3 h0 x squared minus 3 h1 x cubed plus dot 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 and plus 2x cubed gx is going to be, what do I get? 2x cubed h0 of h0 plus dot dot dot. And why am I writing plus dot dot dot? Let me just write one more term here. h4x cubed then this term is minus 3h2x cube x not cube, this should be 4 h4x to the 4 h2x to the 4 plus 2x 2 h1x to the 4 blah blah blah. But what is my recurrence relation? My initial recurrence relation was that hn is equal to 3hn minus 2 plus 2hn minus 2h of n minus 3. And so if I add all of these, I get 0. So on this side, I get g of x minus 3x squared g of x plus 2x cubed g of x is equal to h0 plus h1x plus h2x squared minus 3h0x squared plus h3 minus 3h1 plus 2h0, right? Sorry, let me write this in the same way as others, 2h0 x cubed plus, and this is h of 3 minus 3h of 3 minus 2 plus 2h of 3 minus 3. And so by my recurrence relation, this step is 0, x cubed, x to the 4, again by the same thing is 0, x to the 4, and so on, plus dot dot dot, right? So everything else become after this becomes 0. And now I know the values of h1, h2, h0, h1, and h2. I was told that h0 is 1, h1 is 0, and h2 is 0. And I can plug those in. And so h0 is 1, h1 is 0. Sorry, this should not be brackets. This should be just h1 multiplied by x. Okay, so h1 times 0, h1 times x is 0 times x plus 0 times x squared minus 3 times 1 times x squared plus 0, right? And so this becomes 1 minus 3x squared, okay? And therefore, I get g of x multiplied by 1 minus 3x squared plus 2x cubed is equal to 1 minus 3x squared. Okay? And therefore, my g of x is equal to 1 minus 3x squared over 1 minus 3x squared plus 2x cubed, which I can solve by partial fraction, which is first of all 3x squared over, let me factor this, 1 minus x squared times 1 plus 2x. And this now I can actually factor by partial fractions, which you should have studied in Calc 1 or Calc 2. I don't remember which of these covers. One of the calculus courses you should have studied partial fractions in, and this gives you is equal to 8 over 9, 8 over 9, 8 over 9, 1 over 1 minus x squared minus 14 over 9 x 14 over 9 x over 1 minus x squared plus 1 over 9 1 over 1 plus 2x. And this is my partial fractions. Okay, I have made the partial fraction decomposition. How does that help? Well, I know the power series for all of these. The power series for 1 over 1 minus x squared is I can get this by derivative of the power series of 1 over 1 minus x. And so this is equal to 0 to infinity n plus 1 x to the n minus 14 over 9 summation n is equal to 0 to infinity n times x to the n plus 1 over 9 summation n is equal to 0 to infinity negative 2 to the n x to the n. And so I can write my power series as summation n is equal to 0 to infinity 8 n plus 1 minus 14n plus negative 2 to the n all over 9 x to the n, right? And all of this is my hn because this is my generating function. And now you can check that this is just equal to, therefore hn is equal to 8 minus 6n. So 8n minus 14 is minus 6n plus negative 2 to the n all over 9 for n greater than or equal to 0. And this does indeed satisfy my initial conditions of h of 0 is equal to 1, h of 1 is equal to 0, and h of 2 is equal to 0. Okay, so this is how you solve using the generating functions.